Hello, good everyone. Welcome back to Economics channel. So we are still continuing with our discussion on probability series, and today we'll be looking at practical application of addition and multiplication rules, and I will also be revisiting independent and dependent events. All right, and yeah, so after the class we are going to be having an assignment as usual. Okay, so that's our culture. Now recall that probability of A intersection B equals probability of A multiplied by the probability of B. Okay, the probability that an event is going to happen and the other event going to happen is the probability of the first event multiplied by the probability of second event. So intersection means multiplication of probabilities. All right, and then looking at this is or the probability of event A or event B happening is equal to probability of event A happening plus probability of event B happening, then minus probability of the two of them happening. Okay, so probability of event A or event B happening is equal to the probability of event A happening or the probability of event B happening, then minus probability of events A and B, because you're looking at A or B, so you are going to subtract the impact of the events, the impact of situations where the two events occur together. All right, the formula that I wrote here is the probability of at least one of the events happening, which you've applied before. It's not all. The probability of at least one of the events happening, and then we have probability of this is only A happening because A is happening, B is not happening. Then B is happening, A is not happening. Then probability that the two events are happening. All right. So every formula the formula that I've written here, they are basically for independent events. Independent event, and I think I've explained it before. That independent events are events that the occurrence of one does not affect the probability of the occurrence of the other one. Okay, so if attending this class does not affect your probability of maybe having a good sleep today. Okay, so then that means the two events are independent of each other. Okay, so there's a way to write that. Okay, so how do you prove that an event is an independent event? Okay, let's go to that first. So an event and two events are independent. So that's the way to put it. Two events are independent. So the probability of one given the occurrence of the other one, right, is still same as probability of the first one just happening. Now, for example, if your probability of if your probability of sleeping today, right, given the probability of attending this class, is still equal to your probability of sleeping today. That means your sleeping is not impacted by the fact that you attended this class or not. So those events are independent events. Now let's take it again. If the probability of you sleeping, like maybe for 4 hours today, right, given that you've attended this class or given that you're attending this class, right, it still equals your probability of sleeping 4 hours today. So it simply means that whether you attend this class or not, you're still going to sleep for 4 hours today. Do you understand? So that means those two events are independently related. So the probability of one, given the occurrence of the other one, does not affect probability of the first one in any way. So when we have things like that, we say we have independent events. Two events are independently related. Okay, and then this is the way to prove it. Now, probability of event A equals to probability of B or equals to the probability of A, given that event B has occurred. Okay, again, the probability two events A and B are independent events. If the probability of A, okay, the probability of sleeping for 4 hours today is equal to the probability of sleeping for 4 hours, given that you've attended this class, right? So if the two of them are equal, so that means the impact of this B, right, is not felt. Okay, is not felt. But if the two of them are not equal to each other, then definitely the events are dependent on each other. Do you understand? The events are dependent on each other. Okay, so um how then do we calculate the probability of A given B? Do you understand? So the formula for that, which is what we have here, is a simple thing. It's simply the probability of A and B divided by the probability of B. Now, a quick way to kind of understand this is if you write A intersection B, then definitely B is what is going to be underneath as your denominator. Do you get it? Then if you write B intersection A, then A is going to be what you have underneath as the denominator. Like that's just like the gist. Okay. So if you're looking at, let's say in that case, you're looking at probability of B, right? So that would be equal to like a probability of events B intersection A, then given that event A has occurred. Okay, so if probability of event B equals to the probability of event B, intersection A, event B and A, right? Given that event A has occurred, right? If both of them are equal, then event B and event A are independent of each other. But if they are not equal, then they are dependent on each other. So that's that about that. So now, having understood this, don't worry, there are going to be examples, to solve and prove our points. Having understood this, then let us go back to what we have here. So when you're looking for the probability that two dependent events will happen, now what we have here, the probability that we have, where is it here? The probability that two independent events will happen. So we just have probability of A multiplied by the probability of B. That's fine. But when we're looking at dependent event, it is if you have probability of A intersection B, so it's probability of event A multiplied by the probability of event B, given that event A has occurred. It's too much, right? Don't worry, it's little by little. Okay, probability of A and B happening, because the question will tell you if the events are dependent or independent of each other. Right? So probability of A intersection B is equal to the probability of event A happening multiplied by the probability of event B happening, given that event A, that you have here, has already occurred, has already taken place. Okay, so that's that about that. Now we could also rewrite this, right, in terms of event B. So this will just be probability of event B multiplied by probability of, are you getting it? You already have event B multiplied by probability of event A happening, given that event B has happened. Okay, so B is standing on its own, right? Probability of event B. So B has happened now. So now what is probability of event A, given that this B has happened? Do you understand? You are still looking for A intersection B, so you could express it this way, this way. You should get the same answer. Okay, so probability of event A happening multiplied by A has already happened now. So what is the probability of B happening, given that A has happened? This. Now you want to express in terms of event B. Probability of event B has happened, right? Because B is the one going first. Probability of event B multiplied by the probability of event A, given that B first happened. Okay, so now if you want to express this guy, let's say we're given values, we want to solve. So B, probability of B, given that event A has happened, will be equal to the probability of B intersection A, right, divided by the probability of event A. So if this was what we were trying to solve out. So basically speaking, we are saying that probability of A intersection B, like I got this from what we did here earlier. So like this one is A given B, so that's how you have A intersection B divided by probability of event B. But now this other one is what is it? This other one is B given A. Yes, as like just do a little rearrangement. Your answer here is same as your answer here. What is changed is just your denominator. Alright, because B intersection A intersection B, they should give you the same answer. Are you following? Are you following? So no, it's getting a little bit complicated, right? Don't worry, just take a chill pill. At this point, take your popcorn. You have a drink beside you, just take it, right? Okay, and then go back. It's little by little. You're going to be able to like get the whole thing. All right, we have an example to solve. So here, a conference center has two meeting rooms, right? So the probability of booking room A is 80%, so that's like 0.8. While the probability of booking A and B, okay, probability of booking the two rooms, okay, simultaneously is 20%. Now, what is the probability that if both what's the probability that if both rooms are independent events? So like this has told you, if both rooms are independent events, so what's the probability that A, room B is booked on a given day? So now that we've been told that they are independent events, so we are looking at this formula here, right, for independent events, and then everything that relates to independent events anyway. All right, then B, at least one auditorium is booked. At least one auditorium is booked. So we are looking at this formula here. At least one auditorium is booked. You book only A, you're not booking B. You book B, you're not booking A, and then you book the two. Now, auditorium A or B will be booked. A or B, A union B. All right, so we just use this formula. Then number two is booking room A independent. How did I write? Independent of booking room B. So the rooms are the same thing as the auditoriums. Okay, just use interchangeably. Independent. I don't know if I was dreaming. I'm probably hungry. No, I'm not. Just manage it. Okay. What we have there is independent anyway. Alright, so now we begin to like solve. So I would have like above these formulas. I believe at this point you have them in your notes. So I'll just begin to apply them. Alright, add them in your notes, and when we begin to pick them one after the other, you'll flow. Alright, so let's begin to break this question into smaller particles. Okay, the probability of booking room A is 80%. So let's start with that. We are answering question A now. So probability of booking event A, room A is 80%, 80%, and this is equal to 0.8. Then um, probability of booking A and B simultaneously. So A intersection B equals what is 20%? Very good, 20%. So the question is saying that what is the probability of booking event B? So that's like the question mark. All right. So since we've been told that they're independent events, so we have this formula. There's a formula that relates the three together. So you have A intersection B equals to the probability of event A multiplied by the probability of event B. So now A intersection B is 20%, which is 0.2. So we have 0.2 equals probability of event A 0.8, then multiplied by probability of event B. We divide through by 0.8 as 0.8, and then probability of event B equals 0.2 divided by 0.8, that's 0.25, which is equal to 25%. Alright, so that's it. Then question B says, what's the probability of booking at least one auditorium? So if you recall the formula for that, so at least P, at least one, let me say one room, so just to save us space. So we have it equals probability of booking A and not booking B, right? Then plus probability of not booking A and booking B. Okay, of course, we understand complements from the previous series. Then probability of booking A and B. All right, so equals the probability of booking A is basically we're given 0.8 multiplied by what's the probability of not booking B? If the probability of booking B is 0.25, the probability of not booking B, that's the complement, where complement comes in 1 minus 0.25, right? Then plus probability of not booking A. Probability of booking A is 0.8, so we have 1 minus 0.8, right? Multiplied by probability of booking B, 0.25, then plus probability of booking the two of them, which is we're given in the question, and that is 0.2. Okay, I hope it's clear. So we have 0.8 multiplied by 0.75, then plus 0.2 multiplied by 0.25 plus 0.2. So when you're done, this is supposed to give you 0.85. Okay, which is like also equal to 85%. Okay, so you can just use your calculator to cross check. Where's my note? All right, so that's it. 0.25. Okay, 0.85. Sorry. So now the last the C part says what's the probability of booking auditorium A or B? Auditorium A or B. All right. So look at it. Auditorium A or B. So probability of booking A or B, which is a union, is a probability of events of booking A plus probability of booking B minus probability of booking the two. Okay, so what's the probability of booking A? 0.8. 0.8. Okay. 0.8. So probability of booking A is 0.8. Probability of booking B 0.25. And probability of booking the two of them 0.2 minus 0.2. This still gives us 0.85. That's kind of trying to give us an inkling. Like, are these events independent of each other? All right. So that's how to solve that. So probability of booking event A or B, or at least one of the rooms, happens to be the same thing. and it's okay. Then is booking room A independent of booking room B? So like that's question. Just have like just erase this question up to this point, out to number two, and then we solve that too. So how do we know if booking room A is independent of booking room B? So we can just use this formula that probability of event A. Let's see if it is no, this is so close. So number two, let's see if probability of event A is equal to the probability of event A given that B has happened, right? So that's what I want to check. Then we know that probability of A given that B, sometimes I just write it like this, like a straight line, some like a slanted line, like it's still talking about um conditional probability basically. So we have P A intersection B divided by probability of event B happening. So the probability of event A from the question was 0.8, and then let's see. No, this is just 0.8. I think we should just solve this one and see what we are going to get. So probability of A intersection B is 0.2, and then yeah, and probability of B happening is 0.25. I think so. So 0.2 divided by 0.25. Okay, is that equal to 0.8? So 0.2 divided by 0.25 is equal to 0.8. Yeah, so definitely you see that here probability of A is equal to probability of A intersection B. No, don't let me even write this like this. It's equal to probability of event A happening, given that event B has happened. So like it doesn't really matter if event B has happened, probability of event A is unperturbed, right? So you conclude that um event A, okay, that's talking about the booking of room A is independent of booking room B. Okay, so and what is the reason? The reason is simply that the probability of booking event A remains the same, right? Regardless of whether room B has been booked or not. Or probability of event A is equal to the probability of events probability of booking room A is equal to the probability of booking room A given that room B has already been booked. All right. I think you may also want to like try the other way around. Let's say you want to use probability of B to test it. So probability of event B will now be equal to probability of event, let's say probability of event B is equal to probability of event B happening, given that event A already happened. So this formula, the formula for this, I just want to kind of write it here. So the formula for B given A would be B intersection A, right, divided by the probability of event A. Okay, so B intersection A is 0.2. Okay, then divided by probability of event A is 0.8. Okay, then recall that probability of event B is 0.25. But when you do 0.2 divided by 0.8, you have 0.25 again because this is basically 1 over 4. Alright, and then that's it. So the same conclusion. So whether you decide to use A given B or you decide to use B given A, the conclusion should be the same thing. Okay, so that's it. That's it. So like thank you very much for this video. Next is your assignment. So now we have the assignment on the board. Based on an online bet for the last two matches of the season, the probability of Man United beating Chelsea FC and Man City FC are 0.4 and 0.8 respectively. The probability of Man United winning both games is 0.3. What is the probability of Man United 1A winning at least one game? Okay, then 1B winning only one game, 1C losing both games. Then number 2 is beating Man City and Chelsea FC independent of each other. Alright, so I think if I were you, I was going to like try to do number 2 first somewhere, and yeah, so to know the formula that I'm even supposed to use to solve 1A to 1C. But it's fine. It's fine. Why I said that was just for me to know if these events are dependent or not. So that I'll just be okay, this is the formula I'm supposed to use. But it's alright, just establish if beating Man City and Chelsea FC happens to be independent of each other, or After Man U has defeated Chelsea, Man U then becomes so motivated to go and defeat Man City. I think we have Chelsea first before Man City. So I'm a Man U fan. In case you want to know, at least for now, Man U for life. See you in the next class. I'll be looking at contingency tables and I think more on conditional probability. Bye. Have fun.